And so now let's compare what we get from a bootstrap distribution and compare that to what we actually get from a sampling distribution. So the code that generated these plots that you're looking at, you can find in the file chap5 compare.r in case you're curious. But let's say now that we're dealing with a population which is up here. Okay, so let's assume our population is normal. It has a mean of 23, a variance of 49. So that 49 is actually the variance there. Then if I pick a random sample, a size 50 from that population, that's what's being shown down here. And comparing the population and the sample, what we can see is since our sample was picked randomly, the mean of the sample is actually very close to the mean of the population, but not exact, right? And so that's the thing that we want to just be careful about when we state these estimates. So from the sample, we see that the sample mean is a pretty good indicator of what the population mean is. And as well, the standard deviation of the sample is actually really, really close to what the standard deviation of the population is. So we can use samples as good estimates for population. The two rightmost histograms or distributions that we're looking at over here, this is the actual sampling distribution. And on the bottom is a bootstrap distribution. So if I didn't know the information on the top row, so if I only had a sample of size 50, and from that sample of size 50, I went through this bootstrap process, here's an example of something that we might get. And so now let's compare this estimate for the sampling distribution, this bootstrap distribution, to what we actually would get if we had population data. And looking at the table, we can see that the means are off a little bit actually, and that my bootstrap distribution had a mean which was a little bit too big. Okay, not drastically off, but it was a little bit off. However, looking at the spread, so comparing the standard error of the sampling distribution to the standard error of the bootstrap distribution, we see that these are actually really, really close. So there's a little bit of bias when we picked our bootstrap distribution. The center of the bootstrap distribution was a little bit off from the sampling distribution, but the standard errors are pretty close to each other. And so let's summarize these three main points that we just made on the previous slide. The first being the center of the bootstrap distribution was actually not accurate approximation for the center of the sampling distribution. So we do have some bias there. So that's the bad side. But the good side is the spread is actually really, really close. So that's great. And the shape of the distribution, I didn't comment on this, but the bootstrap distribution seemed to be normal. And in fact, here's a QQ plot that was comparing the sampling distribution, which is over here. This was the bootstrap distribution on this axis. And this is a normal distribution down here, standard normal distribution. And we can see that the bootstrap distribution is really, really close to shape to the normal distribution. So therefore, we've already commented on sampling distributions are normal. Bootstrap distributions are also going to have are going to be normal. So they're going to have the same shape as well. Okay, so let's look at another example. So here we're going to look at arsenic levels in the groundwater in Bangladesh. And so there's a data set called Bangladesh, which is in the resample data library. And that data set contains 271 observations, random sample of 271 observations, and they recorded the levels of different chemicals in the water, one of which being arsenic. They measured that in parts per billion. So let's say we want to estimate, well, what is the mean amount of arsenic in all groundwater in Bangladesh, based on this sample of 271 observations that we've taken. Well, what would our starting point be to estimate the population parameter, the mean of all of the groundwater, the mean arsenic of all groundwater? Well, a good starting point would probably be to take a look at what is in the sample. So if you haven't done so, you could load the library resample data. Over here, the first line below, I've just created a new variable, arsenic, which is going to store all of the arsenic data from Bangladesh. So we're going to ignore chlorine and cobalt and other variables that were in that data set. And then we're going to calculate the mean arsenic level and the standard deviation of the arsenic level. And I created a histogram of those values. So one thing to note here is this histogram is certainly not normal, right? Our data here is heavily skewed to the right. We've got a big tail going out on the right. We have some outliers over here, here, and here. That kind of makes sense. Most of the samples came back with really low arsenic levels, but they found a couple of samples that had extremely high arsenic levels.